Hello and welcome back to Sheaff Math. In today's lesson, you're going to learn about some special right triangles, and we're going to work through some problems with them. Now let's look at a few of these special triangles. The first triangle is this one, and what's so special about it? Well, it has two 45-degree angles and a 90-degree angle. Okay, we actually call it a 45-45 90-degree triangle. And why is this so special? Well, you can actually solve some problems with this that are kind of easy. So let's suppose that our leg was x, okay, whatever number that is. Well, the other leg, and the legs are the small sides, is the exact same length. That's probably not too hard to figure out. But the hypotenuse, that side across from the 90-degree angle, is exactly square root 2 times the leg in every single 45, 45, 90 triangle. So here's an example. We have this 45, 45, 90, and we're given one of the sides, one of the legs is 7. Well, we know that the other leg is going to be 7 as well. Now, what about the hypotenuse? Well, it's the leg times radical 2. There it is. That's as simple as it is. Now, suppose that you were given just the hypotenuse, 6 times square root 2. Well, if you look over on the left-hand side, we know that the hypotenuse is the leg, which is x, times radical 2. And so you can see that 6 is the actual leg side, okay? And so that was pretty easy because it was set up 6 times square root 2, and so the 6 would be those legs. Now this next one is going to be a little tricky, and I want you to pay close attention. Suppose that our hypotenuse was 9, okay? There wasn't a square root 2 in there, so it's a little different. Now we know that we have to find the x, which is the leg, well, both legs really, and the hypotenuse is the leg times square root 2, and so x times square root 2 equals 9. And so since they're equal to each other, let's set them equal to each other and solve for x. So how do we undo that radical 2 that's multiplying the x? Well, we divide radical 2, we cross that out, and we get x equals 9 over radical 2. But there's a problem. We can't leave our answer with a radical in the denominator, okay? It's a no-no. So how do we undo that radical? Well, we multiply this times square root 2 over square root 2. Why do we do that? What makes that undo it? Well, the top, 9 times square root 2, is 9 square root 2, and the bottom is square root of 4, because you multiply those two. And square root 4 is actually a perfect square, and so we can simplify it to a 2, giving us 9 radical 2 over 2. And this would be your complete answer, your final answer. All right, here's our next special triangle. This one has a 30, a 60, and a 90. And sure enough, we call it a 30, 60, 90 triangle. And this one also has an interesting relationship between the legs. Whatever the small leg is, we'll call it an x, okay? The hypotenuse is exactly double that small leg every time, okay? Now, what does the long leg have as a relationship? Well, whatever the small leg is, the long leg is square root 3 times that, okay? So, for instance, we have this particular one, 30, 60, 90. We have a 4 as our small leg. Well, we know that the hypotenuse is double that small leg, so that's 8, right? Now, the long leg is square root 3 times the small leg, and so it's 4 times square root 3. Now, it's going to take a little while to get used to these, and you're going to have to use this as a reference or write these down. Absolutely. Now, let's take a look at this one. Let's suppose that our hypotenuse was 14. Okay, this is just another way to solve for the side lengths. Well, if the hypotenuse is 14, then the small leg is half of that for this triangle, which is 7. And our long leg would be 7 times radical 3. Still, these aren't too tough of problems. It's just a different way to solve them. Now, let's suppose that your long leg was 5, okay? Now, this is where we have to do a little work. We know that the long leg is the small leg times square root 3. So, we are going to make them equal, okay? And how do we solve for x? We divide by radical 3 on both sides, giving us x equals 5 over radical 3. But we can't have a radical at the bottom, so we are going to multiply by square root 3 over square root 3, giving us 5 square root 3 over square root of 9. The square root of 9 is a perfect square now, and so we can simplify that to 5 square root 3 over 3. And that is our small leg. I know, it's not pretty looking. But now how do we find the hypotenuse? Well, it's double that small leg, and so you just multiply that by 2. And so when you're multiplying this, you just multiply the 2 times the 5, and you get 10 radical 3 over 3. Now, if you were to actually put those in a calculator, it would come out to some crazy decimal, but it would actually make more sense than what it looks like right now. Okay, our last triangle is this one. And what is so special about this triangle? It has a 3, a 4, and a 5 on the sides. Well, we actually call this the 3, 4, 5 triangle because it is very rare in the right triangle world. It is one of the only triangles, right triangles, that has whole numbers or integers as its sides. Most of the time, one of the sides is a radical number. And so what do I mean by that? Well, we know the Pythagorean theorem, a squared plus b squared equals c squared. The two legs squared and added equal the hypotenuse squared. And so for this triangle, when we actually put in those numbers, they actually come out and it works. And it might not seem very special now, but there are not many triangles out there. Now this one is extra special because it's actually used quite a bit in the building industry. Handymen and contractors use it all the time when measuring, using the 3, 4, 5 triangle. Well, there you have it. We talked about 3 special right triangles. Now this was a lot, and I would suggest that you write down somewhere those triangles and what their leg relationship is and hypotenuse, because it's tough to memorize them. And so while you're doing problems, I would say have that handy. Rewatch the video again if you need to try it. They can be a couple of those can be real tricky, but not impossible. Anyway, thanks for watching, and we'll see you next time.